All right, so how'd you do? Mathematical music to my ears. I missed that back in the springtime when everybody was hunkered down at home. Miss all you guys and your mathematical chatter, but nice job with the law cosines. Maybe you weren't 100% sure. It's only been one day, but it is something that you need to know um, to be able to keep working with triangles. So make sure you commit it to memory. Now, triangles, yes, but how about a parallelogram? Sort of mixing in a little parallelogram here. Put this like in a notes category. It'd be something you want to take a little note on. You actually will see a question like this in your homework and probably someday on a mini check or a test. But just kind of want to talk about parallelograms, and you won't be real surprised to see how we can turn them into triangles. As you're maybe jotting down parallelogram ABCD, are you remembering anything about a parallelogram? I'm talking about, do you remember anything about the sides? Do you remember anything about the angles as you're kind of jotting this down? And sometimes there's like some prior knowledge that's needed. As you guys keep taking math, you'll find out that every math course uses prior knowledge. So we'll have you be the guest speaker and come in and talk to the young kids and tell them to make sure they pay attention because you keep using math. So what do you remember about parallelogram? Did you have something, Christine? Mm-hmm. So that's a definitely true and helpful. Definitely true and helpful. The opposite sides are definitely equal or congruent. Hannah? Opposite angles are equal. Now, I happen to not have that up here on the screen, but you guys can write it down if you want, because no doubt this down here is going to be 140 also. So that's a good thing.
The angles like beside each other are supplementary.
Angles beside each other are supplementary. I'm only repeating it because, so yeah, now that means that sort of our missing angle is going to be 40. By the way, if you felt like writing 40 in the other missing angle, like angle B, that's fine because that's true also. Okay, so not hard, but important. So what are we going to do with this? What are we going to do? What? Go ahead. Yeah, actually, I wasn't really sure how you might know, but indeed, we can talk about the diagonals. We can cut it in half. Now, we'll use the word cut in half kind of lightly here because you don't want to start literally cutting things in half. One of the most common mistakes is that kids think that 40 got bisected. It probably didn't get bisected, but more importantly, I want you to realize why that's not helpful. Like, you don't need to worry about trying to come up with these two small angles. Okay, now what I'm showing you here, I would imagine that you guys can also do, but I just want to make sure that we don't create any sort of bad habits and honestly some unnecessary thinking. And so I'm simply implying here that to find the diagonal, all you need is a triangle. And when you look at this triangle, again, it doesn't have to be hard, but when you look at it, it's definitely a side angle side. And of course, side angle side specializes in finding the side that's opposite, okay, which is our diagonal. Now, I just want you to kind of think about how you're going to set this up, because the other point behind this is that, do you realize that we don't have the letter D in any of these formulas? Okay, but we don't need it. We just need to understand that those three formulas are all the same thing. So how would you set this up to find, well, side BD? Just think about it. Kind of give you a little hint that it's still going to be that side squared. And I hope you're trying to think about plugging into the law of cosines, no matter what the letters are. Okay, now the law of cosines is simply the sum of the sides squared. It's the sum of the squares. And then there's always a subtraction of twice the product of the sides and then the cosine of that angle. When you need to, you're welcome to look up here. Again, my point behind this is that it really doesn't matter what letters are on the triangle. It's always the sum of the squares minus twice the product of the sides and the cosine of that angle. It's always good to play along, take a moment, just make sure we only did one problem yesterday, so make sure that it's still working today. Depending on your speed and efficiency of this, you might want to find the other diagonal. I'm going to encourage you to find the other diagonal, which is also kind of an interesting setup. Anything that's bugging you here? Looks like we get 51 for diagonal BD. Okay, please don't hesitate to ask if you need something. I'm also hoping that you'll just take a moment and think about the other diagonal. And again, don't be silly. Don't do things that are unnecessary, like bisecting 140. I mean, if you think about it by the sketch itself, that does not happen. And it doesn't need to happen. Just give you a chance to set it up. Yes, it's very similar, but I want you to process that. Okay, so parallelograms. Kind of like Owen said, if you split them in half, now you're talking triangles. Okay, so a good example of side angle side. We would not have been able to do this problem prior to side angle side. Did you see how it's like basically the same thing, except for the angle. All right, anything for the good of the cause here? We have one more thing to do with the law of cosines, and then I'm going to give you a flex question. A flex question normally is a classroom activity. I think the first one was not, but almost the rest of them are. It's going to be a question that will extend you a little bit, and it usually has something to do with like what we're talking about in class. So look for that. But I want to show you one more thing with the law of cosines. Okay, and it'll be something just that we didn't get to yesterday. It's this side, side, side. Law of cosines works for side, side, side. Okay, let me show you how. Okay, you'll find out that it kind of feels a little bit more like algebra. It feels like you have to solve the equation. All right, a lot of times the triangles are going to be given like this. In other words, I'm just going to list the dimensions. So we've got side A equaling 21, side B 16.7, and side C 10.3. I know it's pretty obvious but it's side, side, side. Now, I say that because when you have a test in front of you and all these problems are mixed up, that is actually the first thing that you want to do. You want to realize that it's side, 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 whether you write it down or just realize it. Now, when it's side, 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 you can make a sketch. Sometimes people are like, do I have to? I think the sketch is, I almost want to say it's essential. Okay, just helps you see how everything's all positioned. I know that you realize this, but it still helps you to see it. It also kind of makes it clear that the only thing that we can find is an angle. Okay, and again, this is a new scenario, but we have to find an angle. Now, it kind of seems like I could find any angle, and on one level, you could, but I'm going to tell you a little secret. If you find the angle that goes with the biggest side, you're going to prevent yourself from creating a no solution possibility. It's a little much to kind of think about, but the truth is, once I get this angle, there's a possibility that the triangle that's before me could be a side-side angle from that chart, okay? And it's a possibility that could turn into a no solution. Just kind of keep it simple. I promise if you find the biggest angle that goes with the biggest side, that'll never happen. You kind of don't have to worry about it.
So, I don't know.
Go ahead. Are you good or?
No.
Okay. Yeah.
So are you saying like we should find the angle of the biggest side?
Yeah. Okay. Now there's going to be, 4 out of 5 times where you do it any way you want, and I got the same answer as he did, right? But it's a little more. I don't have sort of the time to talk about it. I'm just going to be honest. I don't quite understand why sometimes it happens and doesn't happen. But I'm just going to tell you, if you find the biggest angle, you'll never have to worry about this happening. So we're going to find angle A. And the main thing I want you to realize right now is that means that A squared is the one that ends up by itself. That means that this version of the formula has to be used. Okay, so this is pretty important. Since I'm finding angle A, side A is the one that stands over here by itself as it gets squared. Okay, it'll always work that way. Okay, well, you can plug in. You can also look up here if you need to, but I'm just plugging in side B, and I'm plugging in side C. Now, as you plug these numbers in, be ready to do some algebra. Okay, be ready to do some algebra. It's not hard algebra, but it's important. Okay, now maybe kind of like a little step before the step is for me to suggest to you that you really should evaluate these 3 groups of numbers. Okay, because the truth is each of those yellow brackets just represents a single number. So evaluate it, find it. Okay, square 21. Add up the sum of those squares. Now realize that as you do this, that kind of the order of operations would say this is all you really can do. I mean, this is the appropriate way to evaluate these numbers. I also want to share that I think writing these numbers down is also a really good idea. In fact, a lot of times when kids try to just do this whole thing on their calculator, mistakes happen. So don't be too cool for school. Write down a couple numbers. It'll definitely help you in the future. Okay, because this is like the big no-no. The big no-no is when students take these numbers, 384 minus 344, and combine them together. That's a big no-no because 344 has a variable with it. It's not like 384. They're not like terms from your Algebra 1 class. Okay, so don't do that. Don't just take all the numbers and kind of put them all together. Instead, you should feel like it's an equation. You should feel like that you're going to do some inverse operations. Now, I know you guys can do this, but it's the reason we're going over the problem to make sure that you say you're going to subtract 384. Okay, whether you show it or not is up to you, but you subtract 384, you get 56. Don't lose the negative. Actually, folks, there'll always be a negative at this step because there's always a subtraction sign. So don't lose that negative. I hope that you keep feeling like this is algebra and you divide by negative 344. Okay, so we divide by negative 344. Obviously, all that stuff you're doing on your calculator. Now, at this point, you probably get like a big mess of decimals, right? 56 divided by negative 344. And it's actually good. Okay, so 56 divided by negative 344. Okay, because remember, whenever you're finding an angle, because that's what we're looking for, whenever you want to find an angle, you always finish with an inverse. So if you haven't done it yet, do the inverse cosine, and that will give you angle A. That gives you angle A. Okay, so A equals 99. And just kind of have about 1.5 more things to say, because I think that you'll say, yeah, you can do that. But as far as finishing the problem, maybe about 1.5 more things. Go ahead. Ah, shoot. That's, okay, it rounds the same. I don't know why I did that, and I'm on film, but it's 56.02. All right, but good. It comes out the same, so. My fault. You should divide by the decimals. Good.
So I don't remember, how'd you do the A and S? Like I just completely.
Oh, second negative. Even on that TI, second negative. Let's talk about finishing the problem. Okay, to finish the problem, you have 2 options. Sometimes kids like options, sometimes they don't, but I hope that you listen because it just depends on kind of what you want to do. You actually, as you're probably not surprised, could finish the problem with the law of sines. Okay, the reason you can finish it with the law of sines is because you found the biggest angle, and so you don't have to worry about some kind of goofy thing happening, which we're not really going to get into, except to say that you'd be safe, okay, to match 21 with the sine of 99, and whatever you want to do next, maybe angle B, that's what I wrote down, so we'll do that, and go to town. You guys know what to do with that. But listen to this, because sometimes kids are like, yeah, that actually is not a bad idea. You actually could find angle B. You could find angle B doing this. I'll say again, you could do this again. You could do the law of cosines. Okay, now what that means is putting in 16.7 squared all by itself, and of course filling in the rest of these numbers. Now, I know sometimes you're like, yeah, it looks like more work. Well, it's funny. Sometimes it only takes kids to do this a few times and you realize that maybe this isn't as bad, is easier. So anyway, I'm just saying you can do it. You could use the law of cosines again, and you could find your angle B. Now, of course, angle C, I don't think you need to do all this again. You could just subtract. But there might be a time or a place that you feel like that was a smart thing to do. Okay, if you're doing something, or if you just want to feel like you have an answer, I can certainly provide that. 51 some degrees, 51 degrees for B, and then angle C. If you are doing one of these 2 methods up here, they should produce the same angle in theory. But I will say that the law of cosines answer is better because it doesn't use a rounded answer. It's not a big deal. You're allowed to use 99. But let's be honest, this method does not use that answer. It goes back to the original dimensions. Okay, so it really should produce the more accurate answer. and I'll give you credit for either one. Side, side, side. I'm kind of getting a sense that we don't need to like do another problem on the board. That's what your homework's going to be for. Okay, so page 405, we'll find some like regular nightly homework problems. Okay, what I'd like you to do now is to take a look at this flex question where you're going to be proving. Now, as soon as we say the word prove, some people get worked up. So I'll change the language to you're going to show why a 3, 4, 5 triangle is not a 30, 60, 90. Okay, now just listen to that again, because sometimes people think that a 3, 4, 5 is a 30, 60, 90. Okay, but that's actually false. We call it a fallacy. A fallacy just means something that people think is true, but it's really not. Okay, now you're just going to do this kind of good old piece of paper. That's almost always how you do a flex question. And I'm going to say for this one that you not talk to someone about it, because I think you're going to find out that you can do it, even if you're a little frozen for a few seconds. Oh, I should say too, it's on Google Classroom. It's on Google Classroom. It just gives you something to look at. Okay. So pull that up. But what you're going to find is that you're simply going to prove why a 3, 4, 5 is not a 30, 60, 90.
So that doesn't show anywhere.
So good. You're probably going to do a combination of these three things. You're going to show some math. I'll say you need to do that. You're going to show some math. You might show a sketch if it's helpful. And I'm going to say that you need to have at least one sentence that kind of says, okay, this is what I did, and this is why it proves what I'm trying to show. So you can do this, but I'm kind of putting you in a place that, I haven't shown you. So I'm asking you to use any of the math that we've done so far. That would include SOHCAHTOA, law of sines, or law of cosines. So you can use any of the math to try to prove that this is a fallacy.